Hello everyone. Here we are going to discuss on the topic light microscope. Light microscope, which uses visible light as a source of illumination, and transmission light microscope, in which the light travels through the specimen and it creates a magnified image image of the specimen, which is based on the principles of transmission, absorption, diffraction and refraction of light waves. It is made up of more than one glass lens in combination is termed as compound microscope. Compound microscope, which include condenser lens, objective lens, eyepiece lens or ocular lens. Condenser lens, which is focus light from the light source at the specimen, and objective lens, the one facing the object, which is responsible for producing the magnified image available in different varieties, and eyepieces is that one close to the eye. And the power of a lens is described with a number followed by a letter X. A compound microscope with a single eyepiece is called monocular, and one with two eyepieces is called binocular. And both living and dead specimens are viewed through light microscope. The visibility of the magnified specimen, which depends on contrast and resolution. This is the objective lens, forms a real and inverted magnified image of the specimen or object in the focal plane of the eyepiece. And what is the resolving power? It is the ability of magnifying the instrument to distinguish two objects that are close together. And resolving power, which is inversely related to the limit of resolution. Limit of resolution is the minimum distance between the 2 points that allows for their discrimination as two separate points. Higher the resolving power, smaller the limit of resolution. So limit of resolution, which depends upon three factors: wavelength of light lambda, angular aperture alpha, refractive index of the medium surrounding the specimen. And the equation called AB equation, limit of resolution can be calculated object resolution equal to 0.61 lambda divided by NA. The quantity N sin alpha is the numerical aperture of the objective lens, which is abbreviated as NA. For small value of limit of resolution, the numerator of the equation should be small as possible and the denominator should be as large as possible. And the equation shows that the resolution can be improved by shortening the wavelength of the illuminating light, by increasing the index of refraction on the objective lens, and increasing sin alpha. For minimum value of numerator, the wavelength should be small. Thus, the best resolution specimen is illuminated with the blue light of 450 nanometer. The limit of resolution of the unaided human eye is 100 micrometer. Limit of resolution for a microscope that uses visible light is roughly 300 nanometer in air and 200 nanometer with an oil immersion lens. Type of light microscope. One is dark field microscopy. It is a type of microscope in which the objects are illuminated at a very low angle from a side so that the background appears dark and objects show up against this dark background. It's a technique for improving the contrast of unstained transparent specimens. Dark field illumination uses carefully aligned left source to minimize the quantity of directly transmitted light and collecting only the light scattered by the sample. And next is phase contrast microscopy. When light passes through a living cells, the phase of the light wave is changed according to the cell's refractive index. Light which is passing through relatively thick or dense part of the cell, such as nucleus, which is retarded, its phase consequently is shifted relative light that has passed through an adjacent thinner region of the cytoplasm. The specimen appears as different degrees of brightness and contrast. It is used for the study of live and unstained cells, which are in genera transparent to light. This is the phase contrast microscopy, incident light in the stained cells and unstained cells. So that's all about my topic. Thank you.